Welcome back to the deep dive. I've always had this sort of Hollywood image of programming.
Oh, yeah.
The dark room, green text, scrolling down a black screen. It's just you and the machine.
The hacker in the hoodie.
Exactly. A pure, logical, one-on-one conversation.
It's a classic image, but it's not really true, is it?
Well, that's the thing. Looking at the materials for today, the Class 9 notes for CS326 and Chapter 15 of the Mythical Man Month, that image just gets completely shattered.
Yeah.
It turns out writing code isn't really about talking to a computer at all.
That is the big reveal, isn't it? I mean, talk to any senior engineer. They'll tell you the computer is the easy part.
The easy part.
Yeah, the machine does exactly what you tell it to do.
Yeah.
The hard part, the part that makes projects fail, is what Fred Brooks calls the other face.
The other face. It sounds a little ominous, I have to say, like a horror movie.
It does. But what he means is that a program really has two faces. One face speaks to the machine.
That's your bits and bytes, your syntax.
Right. But the other face, it speaks to other humans.
And Brooks argues that this human-to-human connection is actually the more important one. That feels so counterintuitive.
Well, think about it. If the code doesn't run, who cares if a human can read it, right?
Yeah, that's what I was thinking.
But let's play that out. You write some brilliant code today. It works perfectly. But you don't document it. You don't explain the why.
Okay.
6 months later, a bug crops up. Or, a client wants a new feature. You open that file
and you have no idea what's going on.
Not a clue.
I've been there. It's like reading an old diary entry and wondering, who even was this person?
Exactly. And that gets us to the central thesis of the whole chapter. It's this quote: "What we do not understand, we do not possess."
Wow. We do not possess. That's heavy.
It is. It implies if you can't explain your code, you don't really own it. You're just
renting it.
You're renting it from the universe until it breaks. And when it does, if you don't understand it, you can't fix it. The software has rotted.
So that's our mission for today. We're going to dive into this philosophy of documentation, then the tools for it, like JavaDoc.
And then we really need to have a serious talk about the state of the class project.
Yeah, I was looking at that homework slide with the deadlines, and serious might be an understatement.
There is a storm brewing, absolutely. But let's start with the philosophy. Why are we historically so bad at this? The notes say teaching documentation usually fails.
I can guess why. It just feels like chores, You finish the fun part, building the thing.
And then the teacher says, okay, now write a 5-page report about it.
Exactly. It's the eat your vegetables problem.
And teachers usually just explain why it's important, so we know what it does. But they rarely teach how to do it well.
So students just slap on some comments at the end and call it a day.
Right. But Brooks, he points to a specific historical villain in all this: the flowchart.
Oh man, flowcharts. The diamonds for decisions, rectangles for actions. They seem logical. Why does he call them a curse?
Well, think about what a flowchart actually shows you.
It shows the path, the logic. If this, then that.
It shows the decision structure, which was super useful in the 1950s when you were coding in assembly. The structure was really hard to see in the code itself.
You needed a map.
But in modern high-level languages like Java, the structure is obvious. You literally write, if this, then that.
So drawing a box that just repeats what the code already says is redundant.
Totally redundant. And worse, it breaks the #1 rule of documentation: maintenance.
You change the code, you have to remember to go and change the flowchart.
And does anyone ever do that?
Never, not once.
So the map ends up describing a territory that doesn't exist anymore. The documentation is a lie. And that is worse than no documentation at all.
Okay, so flowcharts are out. What's the solution? The notes talk about self-documenting programs.
That's the holy grail. It's the industry consensus. The idea is to merge the documentation right into the source code.
So no separate binder, no separate PDF.
Nope. You put the prose, the explanation, the context right there in the same file as the code.
I have to play devil's advocate here. I've seen source files that are thousands of lines long. If I add paragraphs and paragraphs of text, isn't that file just going to become a novel? How do I find the logic?
That is the classic objection. It'll get too big.
Yeah.
But Brooks makes 2 points. First, disk space is cheap now. We're not counting bytes. And second, the cognitive load of switching windows, of going from your code to a separate doc file and back again.
That's actually much higher.
It's way higher than just scrolling past a comment. It keeps you in the flow.
And I guess most editors let you fold the comments now anyway. You can just hide them.
Exactly.
Yeah.
But the key is, when you edit the code, the documentation is right there, staring you in the face. You're much more likely to update it if it's sitting 2 lines above the code you just changed.
Okay, so we're putting docs in the code, but what are we actually writing? I think that's where people get stuck. Do I comment every single variable? This is a counter.
Please don't do that.
Yeah.
No.
Yeah.
That's what the note's called, describing the trees. You need to describe the forest.
The forest, not the trees.
And the notes break it down into 3 essential buckets. If you only document 3 things, it should be these.
All right, let's do it. Bucket 1, operation.
This is the "how do I drive this car" manual. Don't tell me about the fuel injectors yet. Just where's the gas pedal? What are the inputs? What are the outputs?
So the high-level context. This program takes a CSV and spits out a graph.
Perfect. Bucket 2 is test cases. How do we know it actually works?
The notes mention smoke tests, which is a great term.
It comes from hardware. You plug in a new device, turn it on.
And if smoke comes out?
You unplug it very, very quickly. You don't bother testing the volume knob if the circuit board is on fire.
Right. So in software, a smoke test is the absolute basic sanity check.
Does it launch? Can I log in?
Yeah.
If not, don't waste time on anything else. Documenting these saves the next developer a ton of time.
And then there are the edge cases. The notes split them into legal and illegal.
Right. A legal edge case is weird but valid data, like a user whose name is just a single letter. An illegal edge case is data that should never happen. A user with a negative age. You need to document what the system does. Does it crash?
Or does it give a polite error message?
Hopefully. But you have to write that down.
Got it. And the third bucket.
Future modification. This is the message in a bottle to the future maintainer. You explain your algorithms, your file structures, and this is key, the hooks.
Hooks.
Places where you expect the code might need to change later. You might say, hey, I built this for 3 types of users, but I left a spot here, a hook, so you can easily add a 4th.
That's really paying it forward.
It's humility. It's admitting you didn't build a perfect eternal statue. You built a living thing that will need to adapt.
So we have the philosophy, we have the buckets of what to write. Now the tool. The class slides pivot hard to JavaDoc.
Which is the technical implementation of all of this. It's a tool that parses your comments and turns them into a professional-looking website.
And it uses that specific syntax.
Yes, that /** is what tells the compiler, hey, this isn't just a note, this is official documentation.
And then you have those tags at perm, at return, at author. I'll be honest, sometimes I just fill those in to make the warnings go away.
And that's a tragedy. Think about it. At param is the ingredients for your function. At return is the meal that comes out. If you write garbage there, you are poisoning the well for the next person.
The notes also make another important distinction. JavaDoc is for other programmers, but there's also user documentation.
Crucial distinction. Your end user doesn't care about at param tags.
No, they need to know how to create an account or what to do if they forget their password.
Exactly. The slides call for a common issues FAQ.
And this, I think, brings us to the other face of this deep dive. We've talked about the theory of communication in code. Now we have to look at the practice in this class, because communication seems to be breaking down.
Breaking down is a polite way to put it. I'd call it a crisis of silence.
Let's talk about the everybody somebody problem. The notes quote that little story. Everybody knew something needed to get done that anybody could have done.
But nobody did it. It's the bystander effect. In a big team, everyone assumes someone else is handling it.
And the slides are basically screaming that this is happening right now.
It is. The class officially becomes a development shop on February 23rd. That's a hard deadline. On that day, you are expected to be a functioning software company.
But you need infrastructure for that.
And right now, the infrastructure isn't there.
I saw that note about the requirements team. I mean, that's bad.
It's very bad. The notes say they have not scheduled any meetings with the client.
0 meetings.
As of these notes, yes. And now think about what that means. On February 20th, there's a Sprint 1 planning meeting scheduled.
So that's when they plan the first chunk of work.
But how can you plan a sprint if you have no idea what you're building?
You can't.
If you haven't talked to the client, you have no requirements. If you have no requirements, your sprint backlog is empty. Or, worse, it's just full of guesses.
So you're just running, but you don't know where the finish line is.
You are running fast in random directions. It is a foundational failure for a software organization. You cannot exist without requirements.
And the clock is ticking down. It's not just the 20th and 23rd.
No, there's a whole gauntlet. February 13th, that's just a few days away. Drafts are due for core values and mission owners, wiki plans for design.
And between the 11th and 18th, every single team, front end, logic, gamification, persistence, they all have to set up a 30-minute meeting with the professor.
And the notes imply those haven't been scheduled. The slide is literally a plea. Please set this up.
Why do you think this is happening? Is it just people being lazy?
I don't think it's laziness. I think it's that everybody somebody problem. People are waiting for a designated leader to step up. They're thinking, oh, the project manager's handling that, or the tech lead must have sent that email.
But in a self-organizing shop, you are supposed to be the leader.
Precisely. If you are in this class and you are listening, you have to stop waiting for permission. The whole model relies on individual initiative. See that the wiki is empty, go fill it. Notice the client meeting isn't scheduled. Send the invite.
Be the somebody.
You have to be the somebody, because if everyone waits for everybody, February 23rd is going to be an absolute disaster.
There's one other group the slides call out here, the discussion leaders.
Right, and they have a very specific job. It says their role is not to lecture.
Thank goodness.
Yeah. Their job is to facilitate consensus.
Consensus on what specifically?
On the standards. We just spent all this time talking about documentation. The discussion leader's job is to say, okay, we read Brooks, we know what's good and what's bad. So for our shop, what is our standard?
Oh, I see. So the goal of the discussion is to come out with a decision. Like, we will use JavaDoc for all public methods.
Exactly. A decision that then gets documented on the wiki by the 20th. If the leaders just summarize the reading, they've failed. They need to drive the class to codify the rules for how the shop will run.
It all connects. The philosophy from the Mythical Man Month isn't just some abstract theory.
Hey, look, it's the rule book. It's the rule book you all need to write right now before the doors open for business.
Brooks was warning about this exact situation decades ago.
He was warning about the silence.
Silence.
The silence between the coder and the future maintainer. The silence between the team and the client.
That's a powerful way to put it. We started by talking about self-documenting code as a message to break the silence.
And right now, the class is sending a different kind of message. The empty wiki, the unscheduled meetings, that's a message of silence.
And silence in a project is a vacuum.
And chaos rushes in to fill a vacuum. If the requirements team doesn't break that silence and talk to the client, like tomorrow, the whole class will show up for Sprint 1 with amazing tools and no mission.
The nightmare scenario, a high-performance engine with no steering wheel.
That's it.
So here's the final thought. If you have the power to break the silence, you have to do it. Write the docs, send the email, schedule the meeting. Don't let the project just drift into chaos.
The development shop opens on the 23rd, ready or not.
Make sure you're ready. Thanks for diving in with us today, and good luck.
See you in the shop.